Hey guys, hello to everyone. I'd like to welcome you here at the second session within the scope of our elective subject. Uh, Although, again, it seems that I'm the only one here at this session, but it doesn't matter, I can do it. I'm just going to talk with my computer. We started the previous session with some very basics in our installation, some settings of the environment, some basic workflow type of hello world, how to type a code, where to type a code, how to save it, where to execute a code. So very basics of our. Then we started to talk about data types like numbers, numerical values, logical values, characters, integers, and some special kinds of data types like not a number type, not a value type, or null object. And finally, we moved to some data structures, and we started with vectors, which are unidimensional or one-dimensional sequences, sorted sequences of values of the same data type. And today we are going to follow within this line, keeping the line. So I'm going to continue with the data structures. But for today, the difference between today and previous lesson will be that today's data structures I'm going to talk about are in general two-dimensional. Sorry for this. That's two-dimensional, and matrices and data frames are definitely two-dimensional. But these are kind of special data structures because they are in fact two-dimensional, but the dimensions are considered a bit different within the list because there are something like two different or two levels of data arrangement rather than dimensions to have a flat file or flat file structure, like for example a table or matrix or data frame. Yeah, lists are kind of special, but I'm going to talk about it a bit later. So the next point I'd like to mention now is that I think in the previous lesson took more than 2 hours, more than a half, something like that. I think it was maybe it could be a little exhaustive for you, even for me, for both the sides. So I would like to do the stuff, let's say as fast as possible, but not too much fast, not to make the things, for example, understandable. Just keeping the line, keeping the answer line, but maybe a bit faster than it was Monday, the previous lesson. So yeah, okay. So slides will be available for you, codes will be available for you, and the same rule as at the beginning. I'm going to make a record of this, and I'll try to render it. So if there will be no problem with rendering, I think that the video, the recording of this lesson should be available for you via link to YouTube. Well, okay. So there's a colophon, sensitively published online. I'm interested in some, let's say, rules which should be followed, like Creative Commons license. By means that if you are willing to share the slides, you can share slides, codes, whatever. But you should mention at least my name, or rather maybe name of this department. NC means no commercials, so don't try to do to make any derivatives which should be, for example, purchased by someone. As I told you before, I don't think that anybody will be just willing to buy it from you, but just to make it sure, to make just in case, And no derivatives means that if you are going to make any derivatives, to make any notes, print it out the slides, you can, but in such a case it should be shared after any derivatives or then transformations made in the slides, well, within the slides. Okay, well, so the content, or just the expected content of today's lesson will be that I'm going to repeat what kind of presentations we should know about. As I told you at the beginning, at the very beginning, we started the previous lesson with vectors, with operations with vectors. And today we'll go more into two-dimensional kinds of data structures like matrices, data frames, and lists. So this is today's expected content. Well, for the very beginning, maybe I can just try to repeat, for example, several lines of code what the vectors are, because these are very fundamental stuff you should be aware of. So by supposing that I would like to have a vector x, for example, consisting of three numbers like 2, 1, 3. This is the appropriate syntax how to tell R that I would like to have this vector. X is this vector. You know that I can use a simple an equation mark instead of the oriented arrow mark. Yeah, this works too. Maybe it's easier. So whenever it will be possible, I'm just going to replace the oriented arrows like this by the equation symbols. Both works. Yeah, both should work. But I think that yeah, sometimes, as I told you, the reason why I'm using this is that many beginner tutorials which are published online on the internet, I use this kind of notation like the oriented arrows, but both work. Yeah, equation symbol and oriented arrow mark. Well, so this is a vector. You should know, for example, if I have a vector, a different vector like, I don't know, for example, 10 and 11, why not? There are only two numbers in Y. And for example, I have vector Z, which consists both of vector X and then followed by vector Y. I told you that a vector is a sorted sequence, sometimes called tuple in more mathematical way. It means that we are interested in, so it holds an order of its items, of its values. It's important, yeah, in data science, absolutely important. Because, for example, as I told you, an example, if we are going to make some predictions, we are more interested in, for example, newer or fresher observations than the older one. So usually the newer one usually are listed at the end of vectors or at the end of some matrices with data. So the order of data really matters. So it really does matter. It's important. The Z is just a vector which is just something like a combination of both the vectors x and y. So we can do this joining of the vector, combination of the vectors by C function. It's pretty the same function like for creation of vector from scratch. So Z vector is simply a vector which consists of x vectors, so 2, 1, and 3, and the next and the numbers from x are followed by numbers 10 and 11, which arise from the vector y. Well, so this is the way how to create vectors. If I would like to know about the first item of vectors, that I can do this kind of syntax. So z followed by brackets, and this is the index of the value I would like to know. It's I would like to know about it. So I'd like to know what is the value with an index 1 by running this. Just a quick repetition. I'm running the commands like blocking, sorting in the block like this. I can do it also without the mouse. Block, and by pressing Control and that's the way it should be. Maybe also done by Control and R, I guess. Maybe a Control Enter definitely works. Or even it's possible just to click on a run here in RStudio, like run. Yeah, it also works. But Control Enter usually is maybe more user friendly. Well, the first item here we know, for example, what are the values of the items with indices 2 and 4. This is the way how I can do it. If I would like to, it's 1 and 10. It holds because you can see 1 and 10. 1 is the second one, 10 is the fourth one. It stands. If I would like to know, for example, values of 2, the last value and the second last value, I can do this way. So the second last value will be just, okay, it should be in the lecture, you know. The last value is definitely, there's just a kind of background, you know, line. And, yeah, length of the vector z, you know. And the second last, it's a bit tricky, it's just the length minus 1 here, you know. Where it's 11 and 10, because by running vectors one more time, the last one is 11, the second last 10. So this was about addressing or indexing. Both are synonyms, let's say. And yeah, there are stuff like naming of items in a vector, or renaming, or let's say unnaming. Yeah, this is also important, but maybe not so much like this basic stuff. So how to make a vector, how to extend a vector. It's both done by concatenate function, function, and how to address things, how to address, let's say, given values in pre-existing vector. That's the basic stuff you should know about before the beginning of introduction into the two-dimensional, two-dimensional data structures. I think this is important. Maybe some which I think didn't mention during the previous lesson is that there will be a kind of different inverse or reverse task. If we, for example, know that there is vector z like this, and you would like to know what is an index, for example, of a vector of a value 3, let's say, then there's a trick. It could be derived from what I told you in the previous lesson. I know that if I would like to do like this, like comparison, yeah, I can run this, and you can see that z is equal to 3 in, so not for first, not for the second, not for the fourth, and not for the fifth value, because you know, neither 2, 1, nor 10, 11 is equal to 3, but the third item is equal to 3. So how to get the index? This is not what I didn't mention before during the last session, but we have a function which is very handy. And it's 3. Not to be confused by 3. Value 3 is the third one, so index of 3 is also 3. So let's ask for a number 10. Number 10 is the fourth one, so it should have an index of 4 into it. So which is the function how to solve the reverse task, that if I don't want to know a value of a given index, but I would like to know about the index of a given value, and it's a kind of reverse task. This is the stuff you should know about at this moment, or at least a bit informed about this. Well, so let's start with the matrices. So as I told you, matrix is a two-dimensional array, and it contains all values of only one data type. It means that in all columns, in all rows, there are, for example, only numbers, the numerical values, or for the only logical values, or only character values, or only NA values, for example, yeah, or only integer values. Only one data type for all values which are stored in a matrix. Yeah, it reflects, it really reflects what is the definition of matrix in mathematics. But this is the stuff it's not necessary to know about it, about the theory of linear algebra. Forget on this. Yeah, it's absolutely unnecessary to know about it. Simply enough to know that matrix consists of let's say a number of values, but all the values are only for one data type. Well, so it means that also it's just a rectangle kind of structure. It's just a structured data structure. It means that all columns of a matrix are of the same length, and also all rows of a matrix are the same length. Yeah, it means that, for example, this is a number matrix A, and both rows are of length 2, and also both columns are of length 2. Yeah. Similarly, same for matrix B. So how to do the matrix? Okay, this is what is this important? Why is this important? This is important because you can try to imagine that this is like a very useful base, fundamental base for thinking about data, how data could be stored. Because if you try to analyze a real world data, base measures of real world data are not stored only in vectors, but usually you have more than one columns, or more than one variables, and the variables usually are stored in columns. Yeah. While the observations, are usually stored in rows. So rows stand for observations, columns stand for variables. So for example, if you have, for example, body heights, body weights, BMI indices, gender, or for example, leukemia, whatever we want, these values will be sorted in columns for given metrics or for given data frame. I will talk about a bit later. And in the rows, there should be stored individual patients or individuals objects of your interest, like usual patients in this case. Yeah. So the first patient, second patient, and the last patient. This is natural from the reason that, based on the reason that usually it's simpler to extend your table or matrix with data just to add a last row. For example, it's more natural than to add a last column. Yeah, by extending a matrix by new columns, it's not so much natural. But extended by rows, it's far more natural. Maybe something like a parallel to this in Microsoft Excel, you can realize that while there is, I think, 100,000 rows in a blank sheet of Excel, yeah, so many rows, I think 100,000 in a blank, just in a default blank sheet of Microsoft Excel. There are only several times indices for columns. I think it's just an English alphabet, A to Z, multiplied several times by some special kind of order, like A, B, C, D to Z, then A, B, A, B, A, C, A, D, and this is done several times. So it means that around there is something like maybe several thousand of possible columns in a blank sheet in a Microsoft, but 100,000 of rows. It means that you are supposed to use rather rows for new observations, but only not so many columns, like not so many variables for your data. It's something like a parallel. Yeah. Sometimes called data. Variables in columns, observations in patients, let's say, observations in rows. Data are structured or rectangular data. Well, so back to matrices. This is an important, let's say, starting point to move to data frames. So we are going to go through matrices. So how to make a matrix in R? There is a code. I'm just switching to RStudio. So if I would like to have a, sorry, there's something like, okay, this is better. Well, matrix A. Matrix A is considered this number 1, 2, 3, 4. So I can see that matrix A has got exactly 2 rows and 2 columns, and the numbers are 1, 2, 3, 4, or 1, 3, 2, 4. So how to do it in R? The syntax is that name of matrix means A in this case is equal to, and this should also work, but so I would like to replace it to make it even more simple, or simply for matrix is a dedicated word. Yeah, it means that I'm going to create a new matrix. Then in the brackets, the first argument is a vector consisting of numbers I would like to have in the created matrix. So I know it's just number 1, 2, 3, and 4. Then the second parameter, the parameter of number of rows, and row means number of rows. This is equal to 2. Number of columns is equal to 2 as well. So by this, I should be able to create matrix A. So let's take a look at it. Okay, it's just matrix A, 1, 2, 3, 4. It works, yeah. But I think there are several questions about the way how it's created, because okay, it works. We got the matrix A exactly following the term or following the formula here. So, but it was maybe with a good luck on some accident, a good accident, because there's a big question, and the big question is that how are the numbers from this vector consisting of numbers 1, 2, 3, and 4? How these numbers are sorted or how sorted into creating into matrix which is just creating, or in other words, how is the matrix which is just created populated by this number? So what is the rule? And there are two options. It could be populated by rows or by columns. And this is a big question. You have to know about it, how it works. So how it works? Okay, there's just something like a general rule that if not stated, let's say else, like default in default manner, in default fashion, usually it's not only for R, but it works for many other languages. There is something which is called major column ordering, and this means that these kind of two-dimensional structures are populated by columns. Yeah, the rule is that they are populated. So firstly, the first column is populated, then we started to populate the column from the second column, then the third column, and it's populated from the left top corner. Yeah, it's pretty similar to how, for example, we here in Europe usually just write our texts. Yeah, it means that we usually start at the left top corner of a paper, and we start to write text in the left top corner, and that's pretty the way how it works, populating of the numbers from the vector to the matrix. So left top corner 1, yeah, it works because 1 is 1. Yeah, the first number is in the left top corner. Sorry, it works. Yeah. Then I told you that the rule is that it's populated by columns. So firstly, the first column should be populated. So this is the first column. So 1 and 2, and it works. 1 and 2, yeah. First two columns, first two numbers were 1 and 2, so it should be populated to the first column. And in fact, it is 1 and 2. Then the first column, because we know that there should be 2 rows, so the length of each column is exactly 2. Once the first column is populated, you can go to the second column and following from the next number. So 3 and 4 will be in the next column. 3 and 4, yeah, that's the way how it's populated by following the default manner, default fashion. But sometimes maybe this is something which is typical for programming languages, but honestly for us like humans, maybe this is not so much natural, because you know that usually you usually start at the, if we are starting to just to write some text on a paper, start at the top left corner and we write our text from left to right, then we start the next row, yeah, from the next line from left to right, the next line from left to right. This is at least usually how we write our text in Europe, and this is maybe more natural for us, or at least keeping the lines. Keeping the lines is more than keeping the rows. It's not so feasible for written text here. So this could be changed also in R. And for example, if it's more natural for you to populate your matrix by rows, and believe me, for me, maybe it's more natural for me. This is the way closer to my thinking. For example, there is an argument which can change this kind of manner, and it's argument by row equal to true. It means that the numbers will be populated by rows, simply by rows, not by columns, which is a major column ordering basic rule, default rule. But if I would like to borrow this rule, I would like to populate my matrix by rows, then I have to add an argument, extra argument by row equal to true. As a rule in previous lesson, these spaces are not necessary, but it's better to keep the smart code. It's better because it's more easily, it's easier to follow this kind of code if you are really going to read it 1 month after. And the same thing here, yeah. I'm just trying to keep it some both the logic of the code and both something like a aesthetic part of the code, aesthetic attribute of the code. Well, and the arguments are separated by commas. This is also what I mentioned before, but yeah, just to repeat it. Okay, so by row, it changes the manner of populating our matrix, and let's try to create the matrix B. It means that by my claiming that now it should be applied by row, it means that there should be in the first 1 and 2, and in the second row should be, because there should be also 2 rows, 2 columns. So 1 and 2 should be in the first, in the upper row, and the bottom row it should be 3 and 4. So let's check it. And it holds. 1 and 2 are in the first row, 3 and 4 are in the second row. So maybe it seems like something like a very, very technical detail, but it's important if we are going to, for example, do some metrics, which could be, for example, which could consist of some weights we are going to use in some linear models or something like this. We are going to do some multiplication. This is important, and to know what your rows are and what your columns are. Yeah, so this is important. And maybe just to make it complete, the matrix by this middle command, because there is no additional argument with by row 2, it means that it will be voted by simply by columns. So yeah, 1 and 3 should be in the first column, and it is. 2 and 4 should be in the second column, and it is. And so the last thing we should know about is that maybe you have realized that if I know the length of the vector, it means that how many numbers or how many values should be included in my matrix, in my desired matrix. And I also tried to tell R that there should be exactly 2 rows and 2 columns. It's something maybe kind of fishy, because you know that if I know the length of this vector, I know number of rows, number of columns, number of rows, number of columns. Yeah, these are pieces of information, but I think that only 2 of these pieces of information is enough, definitely, because if I know that, for example, there should be these numbers and number of rows, then definitely, if there are 4 numbers and number of rows should be 2, then definitely there's no other possibility than to have exactly 2 columns. Yeah. So by saying this, for example, it's pretty okay just to remove this piece of information. Yeah, absolutely. I'm going to rerun it, and magically it still exists there. To make it like a proof for you, now matrix A is removed, and by running this command, matrix A exists, and it looks like it should look. So yeah, it's just logic. Yeah. Similarly, it could be only a number of columns equal to 2. It should also work. So it's enough to it's enough to write in your code only one of these 2 parameters, because the second one could be derived from the length of the vector of values which are going to be plated in the matrix, and the remaining argument of these 2. Yeah. So that's pretty easy to understand this. Okay, so this is just a basic logic how to do matrix. Okay, and so this was progression. There are some basic manipulation, some basic operations, and there is a kind of let's say, okay, these are like very basic code. So this is a kind of different matrix. I'm going to create a matrix which is going to consist from letters. There should be first 12 letters from English alphabet, lowercase alphabet A to L, and number of rows should be 3. So we can derive the number of columns will be 4, and it's pretty the matrix like this. Yeah. But I am not going to add an argument and call equal to 4 here, because it's not necessary. By row 2, because it's easier to realize what will be the desired the output matrix: A, B, C, D, E, F, G, H, I, J, K, L. So it's probably by row. So let's keep it like by row 2. Running this, matrix C looks exactly the way we would like to have it, and you can see that the values are bounded by double quotes, and that's from the reason that letters are simply characters, and these are like strings, so these are not numbers, so it should be bounded by double quotes. Basic commands like this matrix, it is matrix. We know class of C is matrix because this is your data structure, which is called matrix. So there's a difference. A class of C is a matrix. So Class is a function which, in case of this a bit advanced data structures, returns for you the name of a data structure rather than a data type of its elements. So if we would like to have what is data type of its elements of our matrix elements, we have to use the function mode. Yeah, mode C. Let's run it. Character, because we know these are numbers, letters A, B, C, D, and so on. These are characters. So data type of matrix elements are character, but the C as an entire data object, data structure is matrix. So this is the difference between the class function and mode function. Yeah. Sometimes it could be handy. Structure, I told you the structure is absolutely the most important function in between all our functions, because it could tell you just in one line, or generally in one line, or in let's say a few lines, what are the basic properties of our object. So it consists of characters. So this first abbreviation is an output of function mode. Then we can see that there are two dimensions, because there are 3 rows and there are four columns. The logic that first information is about rows, and the second one is about column. Its origin is in linear algebra. Yeah? This is something we have to know. It's simply like a fact. Yeah? So the first is for row, the second row after comma is from columns. And this is just a list of the values populated in the matrix. So structure, dimension, sometimes also handy. This is dimensions. We know that there are two dimensions if we are talking about two-dimensional objects. So there are two numbers, and the value of these two numbers is that there are exactly 3 rows, there are 4 columns. Well, sometimes it could be handy just to rename or just to make names, because now neither the rows nor the columns are named or are labeled. So we can, I'm just going to call names for row name C. One of them is populated, so there are no call names, there are no names of rows. But I would like to have some, so I'm going to run this command. If I previously know that there are 4 columns and 3 rows, I can run it like this. It's not like a rocket science. So if I see it, just take a look at my matrix C. You can see that yeah, there are now labels for columns and for rows. Well, so that's it. Well, sometimes could be maybe kind of bothering to have some names, so I can also unname my matrix. Why not? And now matrix is without the labels. Also, it is possible to make the names using the command list, and the first vector is for simply for names of rows, and the second is for names of columns, which could also work. Yeah. So now C is also it's been labeled, and dim names is like if you want have both names of rows and names of columns in one object, you can use the dim names, because you can see that it's kind of dim. So let's say interesting object that we have something like the very first item, the very first slope, which consists of a vector of names or labels or rows, and the second slope, which consists of a vector of labels for the columns. So, and this is exactly what a list is, yeah, but I'm going to talk about it later. Well, rbind is the way that I would like to add a new row to my matrix. So C rbind means that I'm just going to bind my matrix C with a new row. So C, comma, and this is just a new row. You should be aware of the fact that the length of this row should respect the length of other rows in the existing matrix C. So if I know that there are 4 columns, the length of this row should be also 4. It works. There's no need for matrix. I think that this is clear here because you just made it's before this adding of a new row. Well, C bind means that I'm going to bind my matrix C with a new column, C for column, R for row. So the same story here, C and a new column which should also respect the number of rows of the pre-existing matrix C. So it should be exactly 3 values because we have 3 rows in the matrix C. And also A, B, C, D, and then just a new column consider value X. The minus notation stands for removing of rows or columns. So if I have a matrix C and I'm just going to use bracket notations, like not the round brackets, but just the rectangular sharp brackets. So by this, I told you that before the comma there is information about rows. After comma, behind the comma there is information about columns. So this means that I just delete the first row because it's rows, the first row, and keep the rest of matrix C as is. So the result is that I've got matrix C, but the first row is deleted. First row is removed, and there's row 2, row 3, but the first row is removed. If I change this to 3, means that I'm going to get a matrix C without the last row. Yeah. I would like to, by accident, type down number 4. Yeah, this is a tricky because you know that there's no like 4 lines in my matrix, so there's nothing to remove. Yeah, because there's not the 4th row in my matrix C. So this kind of 4 different syntax means that there's nothing to remove. So still I got my matrix C. Yeah. Also, I can, for example, combine this with person or person free variable. So this means, this formula means, or this command means that I would like to remove the first and the third row just by keeping the second row in a matrix. And if there are no information about columns, I would like to put columns just the way as they are. So by running this, I got only the second row because I removed the first and the last one. So the second row is here. Yeah. E, F, G, and E. And also take a look at the fact that there is no like a name or label for the second row. That's from the reason that we can simply realize that now this is only a vector, and vector could have only names or labels for its items, yeah, but not like for its let's say columns and rows, because we know that vector is one-dimensional, so there's nothing like rows and columns. So to make it clear, if I got just structure of this, structure of this. Yeah, you can see that there is just a named character vector, only one dimension from the first to the 4th item slot, E, F, G, H. Yeah, and as attributes are names like C1 to C4. Yeah, but it's a vector. It's absolutely, it's not a matrix, because there should be, in case that this will be a matrix, there has to be comma and numeric information about the number of, for example, columns. And this will be a number of, for example, rows, and the second row will be information before number of columns. But this is just a simple vector. It's only one dimension. Yeah. So there's no comma in these brackets. Well, and this last command is stands for the fact that once I'm just going to run this, I would like to remove the second column by keeping the rest of matrix. So without touching the rows, and by keeping the first, the third, and the last column. But the second column should be removed by this. And this is the first 2, 4 lines are all, but the second column disappeared. The first one, the third one, and the 4th one are still there, so in the matrix. So this is like the basic commands, and the only difference is that you know that this is very close to indexing or addressing, but the only difference which is between the vectors and the matrices is that I have to keep both the dimensions, the row dimension before the comma and the column dimension behind the comma. Yeah. Well, so this was like introduction to indexing. So like to do the indexing or addressing or making submatrices, I'm going to make a new matrix C to make clear to be able to exactly like to have it. So C1 to C4, R1 to R3, ABCD to letter L. Well, this is another way how to do the matrix, and the only extra argument I used here is the dim names, just to include the names within the creation of the matrix, not after it, like using call names or row names, but it could be done even within the creation of the matrix itself. So if I don't know how to remove the lines or columns, it's pretty easy to realize how the indexing within the matrix will work, how it just works. So C and 2 and 3, it means that I would like to know about the item or the value, which is at the intersection of the second column and the third, sorry, the second row, second row, and the third column. Yeah. And you know that second row and the third column is just a G. So we should get G, and it is G. Perfect. The same here, CR2 and C3. This is pretty the same logic, but instead of the indices of the value, I'm using here rather row name and call name of a given row operators, row and column. So we're running this the same, because if we like to pick a value from the second row by R2 and C3, right? So we are somewhere here, yeah, R2 and C3. So yeah, 2G. This is a command for picking the first line. We are before the console line. We are talking about lines, rows. First row, regardless of the values of columns. So all the values of all appropriate columns. So it is a row number 1, the first row, A, B, C, D. Exactly, it should be the first row. Similarly here, this is a command how to get the third column. Yeah, because we are behind the comma, third column. We are not interested in any limitations for rows. So CGK, because yeah, CGK third in the third column. This may be a bit trickier. We would like to have some matrix such that we would like to pick the first and the third row of the matrix C and the second and the third column of the matrix C. It will be done like that. Make sure that you understand this something, because since there is a gap between the first and the third row, I can't use the notation with the colon, like from 1, 2, 3, because this would also include row number 2. Exactly the same here. So by this, I'm getting R1 and R3 row and C2 and C4 column. So it is some matrix 2 times 2. Well, this is also a way how to get given row. It's a row with a label R2. Since it's labeled, it should be bounded by double quotes. And about the columns, I'm not interested in something special. So there is nothing behind the comma. So R2 is just E, F, G, H. Well, if I like to have the get the last value of the matrix, so the value which is in the right bottom, let's say, right bottom part or right bottom corner of the matrix, means that I have to use a dimension for the last row and dimension for the last column. Yeah, in general, it means that if I'm trying to suppose that I don't know that the matrix C is 3 times 4, I know it in this case, but in general, it's not necessary to know it. It could happen that I don't know it before in advance. So this is the formula for how to get the number of rows. So this is also an index for the last row. There's also an index for the last column. So index for the last row is like this 3, because you know a dimension of matrix is two values vector, number of rows, number of columns, and both the values are also possible to be applied as indices for the value which is at the right bottom corner of the matrix. So this is the formula, maybe the most general possible how to get the value which is pretty at the very right, very bottom corner of the matrix. Its number, it's letter L. Well, this is tricky because if we like to have, if from some reason or another, I, for example, could forget to realize that there should be 2 numbers or 2 information of row and column dimensions, or information both for rows and columns, but there's only one number and it still work. I got F. What does it mean? Okay, if there's something like this, we still have a 2-dimensional object, matrix C, but I use only one number, one index for mapping and getting some value, one value. Then the major column ordering rule is applied. So it means that I'm starting at the top left corner here, and I'm counting by columns until I got my index. So I'm just going to count one by one till I would get number 5. So the first, the second, so index of this value is 1, 2, 3. I'm just moving to the next column, the second column. 4, 5. So this is the index. This is the value, letter F, for which the index applying the major converting rule is equal to 5. So by this I got number letter F. Yeah, it works, but maybe sometimes be confusing. So if you just in case that for example some beginner will also meet this, this is the way how it works. But I would kindly ask you not to use this, rather try to use the 2 pieces of information, like two dimensions, yeah, for mapping in matrices. It's easier for beginners. The same here. This is also time will be tricky, because don't be mistaken by this formula or by this syntax. It seems that there's a comma and there's information before comma and information after comma, but don't be mistaken by this syntax, because you can see that this is bounded in a vector. So this is not like, for example, like this. Yeah, don't be mistaken by this, because it means that it's pretty much closer to this than, for example, this. It means that I would like to have I would like to get a value such that its index is 8 and then 9, but I didn't give any information about what is a rule and what is a row or column information. So it means that I also should apply a major column ordering rule here and try to return 2 values for the for 2 values. The first one of the output value should be the E1 with an index equal to 8, and the second one with an index equal to 9. So by running this command, I'm going to get G and K, and by the same rule as in the previous example, I have to count it from the left top left corner and count by columns, not by rows, but by columns. So 1, 2, 3, 4, 5, 6, 7, 8. So this is a 8 for G and 9 for K. Yeah? the result. Also, it works, but also it could be kinda confusing. C number third, and we'd like to have a value with index 13. It should be pretty the same solution as this previous command and line 103. But the tricky part about this is that I'm going to NA value. And what is the reason why I got NA value? Since we know that the matrix C is 3 times 4 matrix, it means that there are exactly 12 values in my matrix. There is no like a value with an index 13 here, because you know there are indexes values with indexes 1, 2, 3 to 12. So this is definitely not available value. Okay, diag C. This is just an intermediate function which returns a diagonal, sometimes called main diagonal. So it's a sequence of numbers such that with outputting of diagonal, I should start main diagonal by a diagonal function. I should start at the top left corner of matrix and go by a diagonal. So from A to F. So I'm increasing both the index of rows and index of columns by 1. So this is just the an item to value with row and column index 1, 1. It's just the index value with in row and column index 2, 2, and just the value in row and column index 3, 3. So from this to this to this. So this is a sequence from A, F, K, A, F, K. So this is the main diagonal. It's not necessary to have a square square matrix like, for example, 2 times 2, 3 times 3, 4 times 4. It's necessary. Main diagonal exists also in rectangular non-square matrix. And the opposite diagonal is something which is pretty similar. If I would start at the top right corner and go in opposite way, so D, G, and J, this would be just the opposite diagonal, not the main one. The main one is much more important for some derivations and computations, for example, in linear algebra and so on, or also in statistics. But opposite diagonal is also something important, for example, from calculation of determinants, but not important for you. But how to get the opposite diagonal? It's a tricky part. Sometimes it will happen, but I'm going to talk about it because there's something which would be interesting for you, like try to think a bit outside of the box. Well, how to do it? The way how we can do it, because there is not like a special function to get the opposite diagonal. Yeah, it could be we can, for example, do our own function or write our function for it. Why not? But it could be done by a simple command. But the first logic is that I'm going to rearrange my matrix C, that I would like to put all the rows, all the columns, but I would like to have the columns, I would like to rearrange my columns in my matrix C in a reverse order, yeah? Sort them in a reverse order. So from the last one to the first one, not from the first one to dimension C of the to the second value for this, but from the last column. So dimension C, you know, it's 4 and 3, yeah, because there are sorry, three rows and 4 columns. So dimension C2 in brackets means that just the second value. So there are exactly 4 columns, right? So from the from the last column, so from the fourth one to the first one is the way how I can rearrange the matrix C. And now I already got matrix C, but just reversed order of its columns. So C4, C3, C2, C1, but the rows are untouched by this. And now if I just am going to call a diag command on this, I definitely the output I'm definitely going to get as just the main diagonal of this rearranged matrix, but in fact this is like an opposite diagonal of the original matrix. So D, G, and J. So by running a diag command on this, going to get D, G, and H, and it's absolutely the opposite diagonal, D, G, and J. Well, okay, matrix algebra. This is really optional. I think that we're not going to go into this in this course. Maybe there's a slide about it, or 2 slides about it, because this could maybe interesting for you if, I don't know, it is important for statistics. I don't want to say that it is not important. It is important, but I think that during the next week, we'll do some linear models, some regression models, maybe even some a bit advanced, yeah, because in opposite or contrary to this stuff, like some processing and some picking of some given numbers and so given values, applying of let's say superior functions to our code, if the data are properly structured and preprocessed appropriately, then it's something like a piece of cake, because if we have properly formatted your data, it's about running one command, very complex command, but we don't have anything about the stuff which are done behind this command. If the data are properly, if the inputs are correct, data are properly formatted, then like running one liner command on properly formatted data, we are going to, if the input is correct, then output will be also correct, which sometimes called garbage in, garbage out. So this is in opposite, it's called, it's said in opposite way, but if you have well formatted input, then we will got well formatted output. And it's really quickly. So it's rather about interpreting your results than about some stuff like, okay, I should rearrange my columns. Now I should pick, for example, the last 100 values, something like that. This is important in part of processing, but not in part of getting, let's say, superior results, like the final results. Yeah. Well, so this is not so much maybe interesting. Maybe just to make sort of note about it, like A and B are 2 matrices. I'm going to make the Hadamard's product. It means that I'm going to multiply these 2 matrices A and B element wise, element by element, pairwise also. So it means 1 multiplied by 5, I get 5. 3 multiplied by 7, I will get 21. 2 multiplied by 6, I get 12. 4 multiplied by 8, I would get 32. This is called Hadamard's product, and it's important for some weighting models of, for example, weighting linear or non-linear models. Definitely it's important, but I'm not sure if I'm going to more into this next week. Matrix product is also important, but rather for some derivations in statistics. It's a bit different kind of multiplication. Yeah, it's in fact about some scalar products for each appropriate rows and columns combinations. So I'm not going to go into details. It's like a level of typical subjects like math 101 on some technical faculties. So forget on this. It could be done definitely. Transposition of matrices is something you know from Microsoft Excel. If I know that A was like 1, 3, 2, and 4, then transposition of matrix A is that I'm going to switch between rows. Yeah, you know that there was just a row 1, 3, and 2, 4, and the rows from the original matrix A are now columns of the transpose matrix. 1, 3 was a row, now it's a column. It was first row, now it's the first column. 2, 4 was the second row, now it's the second column. And that's the logic of transposition. Or sometimes it also said like, if I consider the main diagonal, I can switch the right upper triangle field by left bottom triangle field, by switch them, yeah, like switch them vice versa. It's also where you can see that 2 and 3 are switched. Yeah, this also a way up. It could be the transposition matrix considered how it works. But it's a lot of optional stuff. Well, so it was for matrices, and if you understand how matrices work, we are pretty close to the next data structure. And honestly, from my point of view, data frames are absolutely the most important data structures if you like to work with real data analysis, because matrices are pretty close to data frames, but matrices, as I told you, all of the values in one matrix, in one given matrix, should be of the same data type. So all of the values were, as you can see in our examples, all of the values were either numerical values or letters or the characters or some other like logical could be or whatever. Yeah, but all of the values are the same. But this is not like the situation we usually have if we collect some real data, because you know that for example, in first row, in first column, there could be, for example, some body height, so these are numerical. And the second row, there could be also numerical, like for example, glycemia or whatever. In the third column, there could be, for example, gender, and this is not like a numerical variable. It is like rather like a factor, or it could be string variable, male, female, male, and so on. These are not numbers. So yeah, so this limitation, if I, for example, you know what, just make a quick experiment here. I'm going to quick experiment like this. I'm going to change this number 4 to a character, yeah, by keeping the rest to the same. What will we get? So you know that 1, 2, and 3 are numerical values, but the 4 is a character now. What will be the result? Now we can see that, and this is what I told you in the previous lecture, all the values are now automatically coerced to such a data type which is going to, for example, to less level of let's say information loss here. This means that by let's say by our coercing of 4 to a number, it could be maybe messy because there will be also, for example, A, and R couldn't know that if there is something like a, for example, a numerical string, which could be without any loss coerced to a number, but it could be also a letter, and letter it's not like too much clear what should be equal to A. So by running this command, it's even clearer, because you can see that now all of them are characters, and you know that S1, 2, and 3 were numerical values before this modification. Now all of the values are characters, and it's okay because we didn't lose any pieces of information, because you can simply coerce this manually back to numbers. But this is a character, it has to be character because there's no other way. Well, so it means that what I wanted to say is that matrices are not 100% appropriate to handle real world data, because you can see that if I would, for example, I would like to have something like, for example, female here and male here, like just for example, you can see it. Okay, female and male are characters, that's okay. But 1 and 2 should be, for example, counts or whatever. And this, I would like to have it like as numbers, not like as characters. So as I told you, since there's a condition that all values in one matrix should be of the same data type, the same data type is like it's selected based on automatic coercion if there is something like a mixing of different data types. And that's why matrices are, let's say, they could be used for representation of real data, could be used with some post-processing of recursion or retyping of re-encoding of some data. But we have a better data structure to handle real world data, mixing different data types of different variables. And this optimal data structure for handling real data is data frame. So data frame is also similar to matrix, two-dimensional array, but that consists of columns of values that have or could have different, all the values in one column should have the same data type, but the columns different columns could have different data types. Could have values of different data types. So data types of different columns could be different. It means that we have values in our columns. It could happen that some of the columns have, for example, characters, and the rest of columns have, for example, numbers. And it could be treated this way. Yeah? And it's the way I would like to, for example, represent the real data, because some of the values are naturally rather numbers, and we would like to have it as numbers. It means numerical data types in R. And the rest of the variables, the rest of the values are, for example, character. For example, male, female are simply words. Yeah? These are not like numbers. So yeah, this is the way. And data frame could serve for us in this way, because it respects different data types in different columns of a given data frame. Similar to matrix, all columns, yeah, sure. Sorry, there should be like a data frame, not a matrix, but yeah, I will actually write it up here in your slides. I'm going to share with you. So all columns of our data frame are of one given length, and all rows of our data frame, sorry for this, are of a given length. It means that the structure of data frame is pretty rectangular, yeah? And it's pretty the same to matrix. So really the only difference between the matrix and a data frame is that while the matrix has all the columns of the same data type, all the values of our matrix are either numbers or either characters or either logical values or whatever, but all those are of the same data type. In data frame, columns has its own data type, values of one data type, but considering different columns could differ considering data types. So we know that there are some inbuilt data frames in R. For example, like empty cars, one of the most popular. This is like a data frame which includes, I think, 32 cars, 32 brands of cars, and these are the names of the cars, and there are some parameters, rather more engineering parameters. For example, miles per gallon, number of cylinders. This is a horsepower, and so on. So this is like, for example, if there is automatic or manual full throat, I think, or number of gears, and so on. So we can also get some more information by searching for help by typing a question mark as a prefix. You can see there is just some like a description, yeah, miles per gallons, and so on. So yeah, you can read it if you want to. Well, so this is absolutely railroad data set, some observations in rows and some variables in columns, and that's pretty the way how tight the data, so data ready to be analyzed, for example, by some advanced modeling. This is how it should look like. Another, okay, some basic stuff, you know it from matrices, structural metrics. Okay, data frame, 30 observations, 11 variables. So 32 rows, 11 columns. And these are the columns, and in rows, in each one there is just a one car brand in one row. Cars, empty cars will be data frame. Mode empty cars will be a list. This is something which is not so important about it. Yeah, this is not like, for example, because you know it's gonna be like one value, like for example character or numeric. So it remixed. It usually mixes different data types. Is data frame empty cars? It definitely is true, because it is data frame. Structure areas, yeah, that's a different inbuilt data frame. This is more biological. If you know a plant which is called iris, I can try to look for it. Iris, maybe it's sorry, it's pronounced by iris. I'm not sure now, but Definitely will realize what, yeah, this is this kind of plant, definitely you are familiar with it. And you can see that the, like, these plants, its flower is could be defined by some parameters, yeah, of the parts, yeah, like this. These are like some numerical parameters, like length and weight of sepal and petal, yeah. And by combination of these four parameters in centimeters, there is something like that biologists are able to specify or just to classify the given iris plant into several species, either to setosa or to versicolor or to virginica. And yeah, so this is a famous, also famous data set based, for example, for some classification task. If you try to extract some rules, empirical rules, heuristics, which, for example, stands for the classification rule into either setosa or versicolor or virginica by calling a structure on iris. Sorry, typo. You can see there are really different data types. The first four columns stand for numerical values because these are like the parameters of the plant. And the last column, species, is a factor of the setosa, versicolor, and the last one is virginica. If I would like to have a vector of these levels, I can find it like areas. You know that considering the matrix notation or matrix addressing, I can try to search for species. So this is how a column of a given name could be called. Yeah, I got this. I got the vector with versicolor and virginica values. And if I would like to have know what are the values or the categories, the levels, I can simply call the levels. This is what we try to do with the factors, setosa, versicolor, virginica. Well, okay, now since we know how the Bayesian regression and some addressing and indexing work, and matrices is pretty the same within the database, so we can do it very quickly. Okay, I'm just going to save the empty cards to data because, you know, I'm just going to do some, it was like removing some rows or columns, so not to hurt my original empty cards within my session, I'm going to resave it or just reassign it to a different object. So just for sure not to manage or to modify the original empty cards. So let's do it. So in data, there's now also empty cards here, but it's called data because it's a different object. Collins data, these are just multiple around cylinders and so on, just for a number of carbons, I think, carburetors or something like this. Collins data could be, for example, changed by some rule. The paste function is something which called one piece of one letter or one word or more than one word. Then it took letter C and it took numbers from 1 to, and dimension data. The second value is a number of columns, so 11. So from the first to last column, number of 1, 2, 3 to 11, and the separator between C and this value should be underscore or underbar. So just by running this, you can see I got C1, C2 up to C11. So columns data could be changed by this command just to C1 to C11, so to make it like a check it, C1 to C11 it works. Well, similar to row names, I'll just concatenate R letter with the number of the first to last row, and I will just paste them using the separator of underscore. So row names data, because it's easier for me. Row names data and data looks like this. Yeah. So the row names were changed, and also columns are changed. Okay, by head data, I'll get the first 6 rows of my data. So it's something like a quick function to get a quick insight into my data frame at first 6 rows. If I would like to have, for example, first 10 rows, it's easier to add an extra argument like by commas. All string functions are specified by commas. So still I will work with data, but I would like to have first 10 rows. So by running this, you can see that I got the first 10 rows. Yeah. For example, sometimes it could happen that some interesting, for example, I don't know, some interesting phenomena is not included first 6 rows. So you have to extend number of rows. You have to skim over just to get some idea or some insight about your data. Tail is a very similar function, but it looks at the last 6 rows. Yeah, so it means R27 to R32. Similarly, if I have more than only 6 last rows, I can, for example, change it to last 10 rows. It's pretty easy. Also, both the head and tail function could serve for us like a quick functions to quick insight to our data. R-bind, we know it from matrices. So I would like to bind my data frame with a new row, and this row, maybe it looks tricky, but it's easier. It's just a repetition of 0. And how many times it's repeated? It's repeated exactly by number of all columns, because that's the way how a new row could be appropriately added as the last one. Yeah, just below the last one. So this looks like 11, 0, because we know there are 11 columns. So it is 11, 0, because this is definitely equal to 11. Okay, I could hard type 11 here. Yeah, it could be, and it will work. But this is like a more general approach, because for some large data sets, if there are, for example, hundreds of variables, it's better to not, for example, it's better not to trust, for example, the original format, because sometimes some change could happen during your project. That we are, for example, you can decide to remove, for example, the last column from some reason or another, and it could be just in such a case, your code will still work because of this hard-typed values. Yeah. So hard-typed constant, hard-typed values, try not to use them, yeah, because it could be like a trap for you if, for example, a format of an entry data may change from some reason. Usually, number of rows and even sometimes number of columns, they definitely could be changed, because sometimes, I don't know, for example, your supervisor or whatever, or some, I don't know, some laboratory could just decide just not to include the last column, or, for example, the first column from some reason. There could be some ID, like ID in the first column, and it couldn't be shared because there's something like GDPR. So this could be removed. And if you, for example, if you wrote your code before this removing your code, like trust the fact that, or just rely on the fact that there should be about one more or one extra column. Yeah. So this urban should work. Okay? You can see that I just add last row, which is populated by zeros, and exactly the same logic is in the C bind. I would like to have a new column, which is not named by a special label, also populated only by zeros, and there is a number of rows. So C bind is for binding a new column to your data. You can see that 0 to 12 column, which really doesn't have any special name. So if you would like to have a special name for it, it's better to do it this way. If you have a data frame, maybe easier to see it. Yeah, data frame, and I'm working with my data, like some empty class, but reassigned a new object, and this is the name of a new variable. So I can make it maybe a bit smarter, like C12 12 or C new, for example, let's say, because I can suppose that I know there were 11 columns for C new, and there's just some values. For simplicity, they are just populated by 0 so many times equal to number of rows in my data set. So by running this command, I got a bit modified data frame. You can see there's the last column which is qualified for 0. That is what we wanted to have, and its new is C new. So this is the way how to specify a name of a new column, new variable. Okay, so new variable or new column is the same in your data frame. And minus notation, we also know about it from matrices. This command stands for the fact I would like to remove the first row in my data frame. Oh, sorry, it means that I'm going to get a data frame without the first row. So yeah, it starts now from the second row. There could be also a different number, you know. If I write something like this, you know, there are only 32 rows. So by this, my data are going to be touched. So there are all the rows from R1 to R32. I can also do it like this. For example, if I from some reason couldn't, for example, rely on the first two, or for example, first three rows. For example, there are some, I don't know, there could be some like some error or whatever. I can remove them by this command. Still, you can see R4, R5, R6. Yeah. And since we are before, in front of the comma, we are working with rows. Behind the comma, we would remove the first column. So it starts on C2. Yeah. Okay. Well, so it should be clear. So index addressing also pretty the same. It was in matrices. How it works for matrices. So data 2 and 3 means that I need to have no value which is an intersection of the second row and the third column. So let's run it. 160, and let's try to check it. Data, data. So the second row and the third column, yeah. So this is the way. So number, index of a row, index of a column, yeah. As easy as this. Still very similar. I can use rather, for example, labels instead of indices. For example, if there will be like I don't know, for example, there will be the original labeling as is in empty cars, you know, empty cars, like, you know, empty cars. Well, I don't know if, for example, horsepower is the third, the fourth, or the fifth column, but I know that there is just simply a column labeled by horsepower. Yeah. So sometimes it's more handy to use labels instead of indices. So by this, I should also get from my data set 160 because it's still it corresponds to the first case. This means that I'd like to know what the first row is because I'm in front of the comma. So first row. This is also interesting because you can see that there's a difference between matrix and between the data frame. As you can remember, once we try to get one row, it's one vector, one row from a matrix, it becomes automatically two vector. But here, if I just picked one row like this, I can check it. It's still a data frame. It's a first row. Yeah. In fact, it's a vector. Yeah, because it's a line. It's simply one line of the first row. Yeah. So it's just a line of numbers which correspond to first row. So it could be a vector. Yeah. It's a vector, but honestly, it's good to know that it's the data frame. It's the data frame. So data frame is like a structure which still keeps its data structure without, even in cases that we are going to reduce its dimension by picking, for example, one column or one row. Yeah, that's good to know. So the first row is just the second column. Yeah, still it's like, yeah, this is also a big exception, because you can see that if I'm talking about columns, now it's transformed to vectors. But the logic is that you know that in columns are variables. So one variable in one column of data frame. These are just numbers, for example, of the same origin or same biological origin, or for example, the same biological maturity, same, for example, let's say generating process. So it's feasible if if I like to pick a given column to treat them, even if it becomes from a data frame, to treat them as a vector. But if I'm talking about one row which was picked from a data frame, like in this case, you can see that the first, it's pretty good, maybe even more even better example is this. Yeah, because you know that one row, the first row stands for Mazda car, and first value is for miles per gallon, second value is for cylinders, and so on. So these numbers are totally heterogeneous bunch of numbers, because some of them, for example, it's just miles per gallon, its unit is just miles. Cylinders, its unit is like imaginary, like 1, 2, 3. Horsepower is fine. I think it's just a multiple, it's factor of number of horses, something like this. Yeah, and so on and so on. Weight is, I guess it's maybe in hundreds of kilos, maybe something like this. So it's not feasible to make a vector from totally different numbers of totally different origins. Yeah, it's biological or engineering or technical coordinates totally different. So it's not feasible to make a vector from a given row data, but it is feasible. It is meaningful to make a vector from one column, which becomes from data. So because these numbers are of the same, or the very same origin. Like, for example, if I got the first column of the cars, I know that all these numbers are miles per gallon. Yeah. So yeah, they are very, they could be very homogeneous, because it's, they are measured by the same recordings. They are, you know, I think, yeah, they very present low variability, and I think that it may be all summarized good histogram. Let's try to rewrite it one more time. Yeah. Okay, there's a feasible range from its minimum and maximum from 10 to 35. So this may sound like some tricks, but everything in R is based on, I think, very, very natural reasons for data science, and data science, nothing which, for example, so much far from some, I would say, common sense thinking. Okay, so it was for picking a given row or given column. There's a different kind of picking of a given column. Yeah, it's a dollar notation. You know, something like a dollar notation from Microsoft Excel, and this is something similar, somewhat similar, but okay, I don't know what this. Know what the data stands for. Data works, but yeah, okay, it works. It's not okay. It works. Yeah, so it means that I just got a vector of the fifth column, or just a column labeled by C5 of my data set. But honestly, I don't know. I think much more better syntax is this one, because by this I think I can change this value, for example, by some placeholder and iterate over it using a for loop, for example. By this, not, because you can see that there's like this is like a fixed symbol. So I cannot iterate by this. This is, since it is concatenated with a fixed symbol, it's pretty similar, for example, like it was a plus symbol or multiplication symbol, asterisk symbol, whatever. It's due to it's a fixed dedicated symbol for other thing of columns. It couldn't be changed. If I have different, if I would like, for example, have a histogram for C6, I have to write it one more time like this, yeah. But if I would like to have a plot for all, for all columns, if I'm going to use this notation, sorry, I can try to iterate over this, for example, by some x for cycle, yeah. This is what we are going to do for next time. Next again, 1, 2 dimension data to all the columns, and for example, also I will just only calculate means. It may be also feasible. Yeah, I have to print it out. Sorry, print it out. This is something which I'm going to go more in details for the next session. But what I wanted to say, if I'm using this kind of notation with the brackets, you can see that I can iterate over it. But try to realize that I will use this, like it will be something like $$ and X. This is absolutely rubbish, because there's no like column labeled by X, letter X in my data, because these are MPG, mass per hour, horsepower, cylinders, and so yeah, these are the labels, but not like X. So I have to use, it's far more better to use this kind of notation for addressing or indexing, whatever you want to call it, than this. So from my side, this is only if we are going to meet in some tutorials, and definitely are going to be, because there are still some people within the core R community which prefer this, but the reason for not to use it is absolutely, I think it's clear, than more than clear. Yeah, this doesn't work. This works if I would like to have calculate means programmatically. Don't worry about this. I'm going to talk about it and teach this you during the next lesson. So this also work like the fifth column. This is like the first value of the fifth column of my data set. So yeah, 8 and 9. If I'm going to check it in my data set, it means that yeah, C5 and first value. So this is it, and it really works there. But as I showed to, this couldn't be used for any iterations or any cycles, so forget on this. Okay, this is the way how we can try to get right bottom value. Yeah? So it means that if I have a data frame, this is an index from, till you know it from Matrices, index from the number of rows of my data frame, and it's both the number of rows and also index of the last row. It's still the same number. Similar to this, it stands both for number of columns in my data frame and index of the last column, because R is just number one starting. It enumerates sorted arrays from 1, not from 0, like for example Python or other languages. It starts to enumerates all the sorted objects in R from 1, and for this reason it's easy to map the last just the last item if we are talking about some sorted objects. So this is like the value of the last row and last column. So the value is just the right bottom corner of bottom corner as that I consider something like corners of my data frame. But you know, I try to realize that my data frame is a rectangle, table. Number 2, this is this number. This is what I call it right bottom corner. Data 5. This is also tricky because this is maybe one of the difference, also the difference between data frames and matrices, because in matrices it could work like major column ordering, but in data frame it works like an index of columns. And you can see it. I got the fifth column. Why this works this way in data frames and not in columns, not in matrices? The reason is that like going more into data science, maybe it's not so hard to realize that columns are important, more important for us than the rows, because columns are the variables. Yeah, these are the main. These are just the atomic attributes of our data frames. So columns are more important. So if there's only one number, so there's no comma and the second number for, just to make clear what stands for columns, what stands for rows. Yeah. So if it is only one number in brackets, it means that it stands for column. Yeah. Because as I told you, columns are more important for data frames, because the column stands for variables and variables are more. To make it maybe even more clear, if you have a data frame where are, for example, 5 columns, 5 variables, and you have data, just the same data frame as 100 of observations. If you lost 1 or 2 observations, it's not a big deal. You still have 98 observations, still good. But if you would like lose 1 column, it means that you have only 4 variables instead of 5 variables. So it's a big deal. Yeah, it's much more significant deal than losing 1 or 2 variables. So 1 or 2 observations. So saying this, columns, which stand for variables, are much more important for us than rows, which stand for observations. So it's not stated otherwise. If there's only one number, it stands for column. Yeah. So this is absolutely the same like this and this. Sorry, this and this is absolutely the same. So by this, I'm going to get the fifth column, and by this, I will also get the numbers of column. The difference is that by this, the column is still treated as a data frame. Yeah. So I'm going to take a look at it like this. You can see it was, because it's not in a vector. So if there's no comma, it's still a data frame. If there is a comma, it's a vector. So still some differences, but it holds what I told you. There's only one number. It stands for columns, index of column, not index of a row. Well, column summaries. I think the thing started to be more interesting because this is something which is very, very handy. We are going to start to do some analysis finally. Okay, what is this about? Well, definitely, if we try to consider what I told you 1 minute ago, that columns stand for variables and rows stand for observations. It's feasible to, or sometimes, many times, feasible to calculate, for example, means or summations for columns, not for rows, because one more time, empty cars, first line, first row. It's not feasible just to calculate the summation of miles per gallon or number of cylinders, horsepower, because units of these numbers are totally different. Yes, some of them are miles, some of them are number of horses. I don't know. Some of them are hundreds of kilos, kilograms, and so on and so on. So it's not feasible, but it is feasible, for example, to calculate a mean for the first column, because these are miles per gallon. Units for this are miles. There is some very likely there's a central tendency. It means there is some expected average value. In other words, there is some variability, so some standard deviation. So it's feasible to calculate means. So we can try to calculate. Although summation is sometimes, for example, could be feasible, but in this for our data set, I think the calculation means for each class is very meaningful. So I got averages for first, second, and for the last to the last columns. It's pretty the same like I would calculate for empty cars. Yeah, same numbers. So this is very literally, and I think that this is the way. Still, you can do this in Excel. Like if you do a table in Excel, you can try to employ a function which is I guess called mean or average. So equal sign, average or mean, round brackets, and you have to select your appropriate column, pressing enter, and you can expand your calculation to all columns. So you will get exactly the same calculation. So in other words, this is still not a reason to learn R, yeah, but we are starting to do something more interesting. Maybe this is much more faster than like selecting some columns and calculating and expanding to the whole table. Yeah, you can do it, but this is much more, I would say, much more elegant. It will be also done by this function apply, which consists of several arguments. The first is the data set we are working with. The second number is either a 1 or 2. 1 stands for rows, 2 stands for columns, and we know that calculation, this summary calculations are feasible for columns, not for rows. So there should be almost always 2. And this is just a, for example, in example, there is a mean function, but there could be whatever you want. For example, this function is able to calculate only means, like averages, but this could be, for example, replaced by, for example, more complex function, like, for example, we would like to have, for example, standard deviations. Yeah, still possible. Yeah, but there is nothing like, if I would like to do something like this, like SDS. Yeah, there's nothing like column standard deviations, nothing like this. But you can use this a bit more general function like apply. So apply some function on some data, on some two-dimensional data, respecting given direction. So given dimension. So I would like to apply a standard deviation on my data frame called data, respecting that I would like to calculate it to columns. And so 1 for rows, 2 for columns. Or so this works. Or there could be some variances, for example. Yeah, whatever you want, whatever you like to have. There could be even your own function. Yeah, I'm going to do it also. So this is very handy and very general function. This is also handy. Yeah? Okay, this doesn't work. Let's forget on this. Yes, I should do. It's also handy, but it's very limited. It can also put one data frame, and it can calculate means only for a class. Well, that's it. Maybe one trick. If I would like to extend my data with a new row, last row, which consists only of new not available values. Let's try to do it. So data now looks like this. The last row is now populated by not available values. What does it mean for calculation of col means? Okay, there's a problem definitely, because you can see that there are also only not available values. But I would like to, for example, have some calculations of averages omitting the last not available values, but considering only the first, I don't know, first 32 values which are known. Yeah, This is like a missing value, but the first 32 values are known for each of the columns. So we should get like numbers like this, yeah. So how to do it? How to do it now? How to do it in one way? How to skip considering of not available values in my calculation means, because this manner is like correct, because yeah, we don't know what number is here. It's not available. It's from some reason or other. It's a missing value. It could be 20 here, 40 here, and definitely values of these numbers definitely could affect how the means are, yeah, of the columns. So yeah, but still, I would like to have I would like to know how to calculate the means. There's some extra argument separated by comma, of course, which is labeled by na.rm. It means that if the not available values should be removed, yeah, be careful. It has to be in lower cases. This will work. Yeah, because R is a lower, it's a case-sensitive language. So everything which was written in my script, which we are provided by the scripts, every commands are written in the way how it's checked that it works. Because, for example, here in this command, this large is a uppercase M, and yeah, it's important. I'm going to replace by lowercase m. Stop to work. So it's case sensitive. It's important to respect uppercases and lowercases in commands. An example of language which works in a different fashion. For example, it doesn't matter if the cases are upper or lower. It's SQL. It's just a database querying language. SQL. Maybe you've heard about it. But R is case sensitive. So it really does matter if there are upper or lower cases in the commands. It totally changes the story and even the functionality. So NA remove, since or still we know that NA value are in uppercase, but there's NA in lowercase, and so it means that true means if it's equal to mean that okay, remove firstly all NA values, not available values, and then calculate the means for each columns. Now it works, yeah, now it works. And similar to apply function is very very able to be adjusted to this kind of situation. So you can see that there are still data. So what to apply mean on which data set, data frame on data, following the columns, not the rows. And there is one extra comma, and I simply added an extra argument, and rm equal to true, and apply is going to understand it, and it's going to apply columns, the means for columns. Okay, so that was for data frames. Absolutely important for data science, because we all the time we working with empty cast data frames, which is real data frame. So real data frame. So yeah, this is like the way how it's going to be, how the data could look like before we are going to apply some more advanced statistical functions on them. Lists. Okay, the last part. I'm going to do it really fast, because in this course I think that we are not going to work with lists so much. So a list is a kind of very special data structure, because it's something like two levels data arranging, and I'm going to explain this. So list is in fact a tuple, so it means that it's just sorted sequence of items, and each of the items would have its own data. It could include its own data structure or data type. So it could happen that, for example, we have a list. Maybe it will be absolutely more clear for you to make an example. So I'm just going to introduce a new variable, new object, which is called my list. by using a list. This is a reference word. So this is something like, for example, C or matrix, yeah, list. And this is like the syntax how I can make the list. So just to make the indentation. So okay, maybe a few words of organization. All the time you can see that I am using something like some white spaces. Yeah, these spaces are really not necessary. I can do it this way, for example. So it doesn't matter. Like this, you can run it, and yeah, it seems to work. Okay, I got my list. I will comment it later, but about the indentation, my list. I'll remove it for now. So the indentation doesn't matter. Yeah, of course, in some languages like Python, the indentation is absolutely crucial, but not in R. So it's more user-friendly, saying this. But it's better. It's better to make your code easier to follow, for example, for your colleagues or for your supervisor or whatever. Even for you, for example, 2 months later, you are going to go back to your code and make some, for example, changes. So I really prefer to do the indentation. So it's not necessary, and it could also look like this. Why not? Still, it will work. Yeah, it still works. My list is also here, but try to make a code which is easier to understand, easier to understand for your colleagues or whatever. Well, so what is a list? So list, and I'm trying to do the stuff like I would like to have a first item which is labeled by lowercase a, and it's just a vector of integers from 1 to 10. Yeah, comma, of course. Then I would like a second item, which is labeled by B, and it should be a data frame empty cast. This is what I told you. All of the items could include an absolutely different data structure, whatever what data of your interest or of your focus. It's absolutely irrelevant. The items are independent, mutually independent. So in the first item, there is just a vector. Yeah. In the second item, labeled by B, there's just a data frame. In the third item, labeled by C, there's just a matrix. Yeah, with 2 rows. Yeah. If there is no state, otherwise the number stands for number of rows, and not for number of rows, but for number of rows. So not like numbers 1, 2, 3 till 8, and in 2 rows. And the last item, which is labeled by Z, it's just simply one constant value, character value, hello. Yeah. So let's run it. Let's execute it, and my list is a really complex structure because my list A, this is the vector of 1 till 8, integers from 1 to 10. My list with item B, there's empty cars. Yeah. In item labeled by C, there's the matrix I told you, 2 rows, 8 numbers, and in slot labeled by Z, there is a word character hello. So very complex structure, and this is absolutely the way why we sometimes need lists. Yeah, because sometimes we have, for example, very complex, for example, outputs from one analysis, and we like to keep it under one roof. So we use lists to make it in one object, one more complex object. And what is also okay, I'm going to talk about it in the other session, yeah, because I started to talk about the fact that there are 2 levels of arrangement. Okay, just to make it clear what I meant by this. My list, like if I would like to, for example, get from R, which is the first value, or just the first data, such a first item, first slot, I can see that this is just a vector of numbers 1 to 10. I also could use this transition by addressing by letter, by label. Okay, yeah, but you know that okay, we can see it if this is just a number, so vector of numbers. I think, for example, I could be interested, for example, in first three numbers. Yeah. So how to do it? Okay, I can suppose that this is like vector. Yeah, there could be some something more tricky, but let's suppose. So I would like to have first three numbers. It seems not to work. Yeah. Why? Because you can see that, as I told you, there are two levels of data arrangement, and still this is a list, in fact. Let's try to check it. Structure. It's still a list, yeah. So to respect the fact there are two levels of arrangement, I have to use double brackets to pick my, or just to get my vector output. This is just the first level of arrangement, and now I can really touch, for example, put, for example, you know, 1 first, the 4th, and the 7th value. Yeah, no surprise I got this, but now it works. Now it works. So there is a difference between list and all the previous structures, because this is in fact a two-dimensional structure, but in a different way of representation of data than, for example, the matrix or data frames use, because you can see that there are really this tricky part, or this unexpected part, that we have to use double brackets to get our values of our items or objects which are stored in the given items and slots. So if I would like to have, for example, the second item called B, we know that there is in fact empty cards, and if I forgot to use the double quotation, it seems like pretty the same output here, but there is that you can see that there is like $B. It means that we are still working with lists. So by this, if I would like to have, for example, the second value, sorry, the second row and the third column, yeah, the value of the second row and third column, I didn't get nothing because of I forget to use double quotations. Now it works. 160. This is what we know from the previous cases. To row 2 and column 3. Now it works. So don't forget to respect the second, the two-level arrangement of data, and to get to your to data structures which are stored in the slots. To make this smoothly, you have to respect this special kind of arrangement and use double brackets to pick exactly the data structures which are saved stored in the items, in the slots of list. Well, so back to the yeah, if I would like to have something like structure of my list, sorry, I can see it. I can see this is a list, and this is like a summary or a structure of my list. Item or slot A is populated by vector 1 to 10. Slot B is populated by data frame empty cards. Slot C is populated by two-dimensional matrix, simple matrix, and slot C is populated by a character hello. Class list, list. Mode on my list is also because there is no one data type, because only the second item consists of different data types or different types. So there are some numbers, some characters, integers, and so it could be like only one data type is output for you. And if it is list, yes, it is list. Okay, how to, for example, if you have a list, you can also have an empty list. And how, for example, to extend your list, how to make new slots to your list. So I know that names of my list are A, B, C, and Z. This is the way how I created my list. Now I'm going to use letters from 1 to the length of my list. Oh, my list is number of slots, number of the items, for because there's A, B, C, and Z. So now I change the names of my list to the first four letters of uppercase English alphabet, A, B, C, D, why not? And now the logic is that I would like to give the new slot, the fifth one, which is populated by a vector of true and false. Yeah. So how to do it? Still, I have to respect the arrangement of the two-level data arrangement. So I have to use double quotations, my list and double quotations, and index of the fifth or the last new slot is equal to the length of my list, which is stands for a number of existing slots. For and the new one will be with an index of one, yeah, larger one, yeah, just one up, yeah. So it will be just the fifth. It will be 5. So in a new slot with index 5, we can try to store a vector of true and false values. So let's try to run it. My list now looks like this. Okay. A, B, C, D, there is nothing new, but the fifth slot includes earlier a vector of true and false. This is okay, this is correct. This is the way how we want it to have. But there's no name. So how to name it? Now it's important to realize that once we added the new slot to our pre-existing list, the length of my list is already equal to current number of slots, and it's 5. So the fifth one, the last one, is D1, which is not named yet. So names of my list are A, B, C, Z, and like an empty character. Yeah, empty character. So the fifth one, and don't mistake by this, since the names of my list are simply a vector, it's not like a list, this is simply a vector. You can check it by structure. It's just a vector of character. Yeah. So now simple brackets are enough. So names of my list of the length of my list, which is equal to number 5, should be our new name. Yeah. So I just choose to have it like X and Y. Why not? So let's run it. My list now looks like this. So A, B, C, D, and X, Y. So it seems to work. So this is the way how we can extend the pre-existing list. Indexing and addressing in list is tricky, but I've already introduced it. So if I wanted to have the second item of my list, which is the empty cards data set, if I would like to have it in proper way, ready for some, for example, under modification, some other analysis, ongoing analysis, or whatever, I have to use a double brackets quotation. So still, I can use labeling instead of index. Yeah. This stands for second item. This stands for the item with a label B. We know that these two are the same. Yeah. If I accidentally forgot to include the double brackets, I still got something very, very similar to the previous output, but you know that while now I cannot, for example, attach the second value of the second row and the fourth column, because yeah, equal number of dimensions, I have to include the double brackets here, 110, 2, and yeah, this is here. Now it's correct. So to make it possible, don't forget to use double brackets for the first level of the data arrangement in lists. Yeah. This means that I would like to have the second and the fourth items, and to make the things even more complex. Yeah, this is really interesting because while this makes perfect sense, I would like to get the second and the fourth item of my list. This is something like I would like to have a combination of the second and the fourth item but exactly, I don't. I honestly, I am not sure what this stands for, because just a vector of. It seems that there is like a, yeah, yeah. It means that there is like a, it seems like the second item and the fourth column of the second item. But this is really confusing. This syntax is really confusing. Don't use it. So this is okay. This stands for the getting the second and the fourth item, because we know that if we know like a single brackets, we can put the items as sublist, still list. So there are no any big thing. But this is really confusing. Yeah, don't use this. I can also use the dollar labeling, dollar notation, but you know that I just tried to show you why this is not much more useful regarding the fact that it's not possible to be handled by, for example, some for loops. My list, the first item and the second variable number 2, yeah. This means that it's the second item and the third row and the fifth column, because it's from the empty cards. I try to look at it. The third and the fifth. 3.55. It works. Well, we are almost finishing the slides. Okay, this slide, there is just I think it's not important to understand properly what is in there. Are something like a sample function and apply function. Okay, so just to make clear what happens on this bunch of code, on this code snippet. The first let's see is here to to fix the core of my pseudo random generator of numbers. So yeah, to make it available. So once you are going to use this, you are going to use this, apply this code or run this code at your computers, you are going to get exactly the same numbers. Yeah, this is something like to how to fix the randomness, how to share the exactly the same numbers between different devices, different computers. Yeah, and next code is that I'm trying to pick randomly sampled numbers from 80 to 120, exactly 100 of this randomly picked numbers from 80 to integers from 80 to 120. It could be replaced. Yeah, for example, it could be for example 2 times or 3 times, for example, 81. Why not? And this code means that I would like to have a different number. If I, for example, yeah, there will be different numbers from 50 to 150 within each of this vector of a different length. So in fact, in the end, I'm going to got this. It will be long list, the list, I'm sorry, my long list. The list consists exactly of 100 items, but the items have got different lengths. So this one is definitely shorter than this one, and similarly this is even shorter, and so and so. So the numbers within each item are random, and also this is the first attribute of random for this vector, and the second is that so first the numbers are random, and lengths of these vectors, which are stored within each of the item, are of a random different lengths. Yeah. Because by this code, I wanted to simulate it sometimes, typically in biology, or for example in meteorology or hydrology. You can have some sensors which, for example, measure some signal only given some condition. For example, if we have level of a river, of a water in a river, yeah, you can, for example, it's usually measured only if, for example, the water, the level of water in a river triggers some basic, yeah, some basic value. Yeah. If it's if the level is higher than some basic level, if, for example, some floods are in risk, something like this, then in such a case, these kind of measurements or these kind of records or these kinds of tools are started to measure what are the appropriate height of the water level in a river, for example, with precision on centimeters. Yeah, but it started to measure because we are not interested in a level of water if there is a very low water in a river, yeah, because no floods are in a risk, so we can't expect any floods. So this was just an application, you know. Yeah. So it means that sometimes we can get a different, for example, different values, for example, for different days or for different weeks or for different time intervals. This is pretty common situation in biology and some biological sciences, yeah, or in some earth sciences, agriculture sciences. And still we have to use this because what is the implication of this fact that for example, as I told you about the measuring of water level, sometimes it's not even measured, so we have no new numbers, for example, for days when there is low water in the river. But sometimes if this is just a high level of water, it's for example measured on for example 10 minutes basis, something like this. So within these days, for example, when it's for example raining or something and the water is very high, then we got many numbers because the trigger is met. Yeah, the trigger is because the water is higher than the triggering value. And within the other days when there's some very dry weather, there could be very low number of the values since the trigger height from which the risk of floods started to be feasible is not met. It's not reached by the level of water. So yeah, all in all, anyway, different numbers of values for different days for different intervals is pretty common solution in biomedicine or in earth sciences. So how to handle it? It means that if the vectors stored in different items couldn't be sorted in data frames or in matrices. Why? Because we know that their lengths could be pretty different, and they definitely were. They are different. You can see it, and this one is longer than this one, and so on. So since it couldn't be, for example, neither as columns or rows for a matrix or a data frame, from the reason that it could be like sorted or arranged in a rectangle kind of table. Yeah. The lengths are different. So that's the way when that's the case, typical case when usage of a list is very appropriate. Or on the other hand, maybe this was one of the very few options we usually have how to handle this kind of data. So this is like generated data, but it could, for example, simulate the situation within the measuring of water level in a river, for example, yeah, based on the weather is dry or wet, yeah, something like this. So sometimes it could be interesting, for example, calculate, okay, for example, to know about, for example, the first value of each of these slots. So if the first value, for example, the very morning value or something like this, it could be, for example, interesting because if you know, for example, the very morning value, you can expect if the day is going to be full of troubles, or it could be, for example, it could be, you know, not so much, for example, risk for you. So by this code, we can do it. Apply is the function we can do it. My own list is where we are going to apply this. The next argument is a bit tricky. This is something which is very hard to Google for because how to like call this. That is like this is a symbol which stands for the second level of deepness, level of deepness of your data structure arrangement. It means that we are interested in our list, which is called my list, but we are interested in the first values within our slots, yeah, not like with our first slot, which stands for our first day, but we are interested in the first value of each of the slots. So it means that there are 100 slots spent for 100 days. We are interested in the first value for each of the days, each of the slots, in other words. Yeah, so this is the way how to do it. By this, we are going to get the, I think that this number stands for the first slot here, but this is a bit confusing. Let's do it like this. Yeah, maybe it was the same. I'm not sure. Maybe it could also work, but this is the appropriate way how which will be general. So the second level of definitiveness. Okay. Well, then what is also interesting? For example, we could be interested in calculating of means for each slot. So one more time, we are taking a look at our list. 100 slots for 100 days, and we are, for example, interested in calculating a mean for this slot or this slot, because calculating a mean value for each one of the days, each one of the slots, is very easy, because by this value we can know, for example, how the day was. If it was, for example, in more risk or in lower risk, for example, in some floods or something like this. So you can take a apply function, apply it on my log list, and this is a function which we like to apply, and this is the mean value. What is also important or could be interesting is the max value. What is the maximum, for example? What is the maximum value? So we can see that maximum is sometimes where it could be a number, so we know that it was limited by a number of 150. But it is just an illustration, not the real data. Okay, also interesting could be how many numbers are in different slots. It means how many times the trigger value of water level was hit by the water. So how many recordings are per each day? So we can see that the numbers are very different, and the story behind it could be, for example, if the number is high like this, it could be a day with, in general, more time points where the river level just met or just hit the trigger height. Or, for example, and if there is low number of, it means that it was, for example, in general, more dry day, more dry weather, something like this, and the number of time points where the water level hit the trigger height of water was just not so much large, something like this. Okay, it's very handy because if you realize how the list looks like, it looks like this. So if we, for example, would like to know, for example, the first values of each of the, in fact, without knowing of this addressing functions, we had to construct or type down a for cycle to put iteratively each of the items, each of the slots, and then put the first value of a vector stored in each slot. Yeah. So in fact, that will be at minimum at least one for loop. Yeah. But this is really much more user comfortable for an end user. Well, so it was about list. The last thing I will just add to this slide is that I've just listed some, let's say, references or maybe some literature I can recommend you to if you have some time. I don't think so. Well, Hedlevigam is sometimes called as a father of modern R. He wrote a book called Advanced R, but I think that this book would be for example, interesting only for someone who is maybe not so much newbie in R. So maybe after 2 years of working with R, this book maybe could be something for you. So it's just a piece of information for you. And the first book, Beginner's Guide to R, if you have a possibility to, for example, learn it or just to buy it to you, or just to get a PDF copy. I think that it could be, for example, reachable somewhere online. So if you would like to, I think this one could be recommended from my side. But on the other hand, I will say that these presentation, my slides and the codes, I think that they are absolutely enough for you, maybe more than enough. So don't worry about the books you don't want to. Well, so it was, I would say that this is enough for today. We are almost in time. So I'm going to render the recording now. Let's hope that it will be successful. I can share the video on YouTube and share the link to YouTube video too. And for the next lesson, we are going more into some ways how to import some data into R or export some R objects from R session to, for example, local drive. It's very important because if we are going to do some real data analysis, you are going to use your external data, and sometimes it will be tricky how to get your data from, for example, some exotic kind of formats just from your flash drives or from local drives or from some cloud to R session and work them, refer to them in R, analyze them and whatever. And then next or just opposite kind of task is how to save or appropriate or R object of your interest back from R session to let's say some suitable formats to localize, like some plots or tables, or I don't know, some microsoft tables, some plain text, and some LaTeX code or whatever. So generally or particularly we are going to work with some plain text, some CSV like comma separated values format, and some Excel files like with files with surfaces dot XLSX. Yeah, these are typical ways how we can handle the data, how the data are usually stored. So these are the formats we are going to try to import to R, and then outputs should be also exported to Microsoft Excel or to plain text or CSV, comma separated values, something like that. So this will be part of next session content, and then we try to consider our more programming language. So we are going to work in some flow control aspects like if statements, some cycles like for loops, while loops, so for, while, do, until, repeat until, and some error and warning handling. And also there will be some time I'll try to show some optimization, like using some apply functions, how to, for example, make your code like a bit faster, execute your code a bit faster with some easy optimization, using some, let's say, well-optimized inbuilt functions in R. And it's sometimes handy to apply this, for example, or especially on a parts of analysis, which is sometimes called bottleneck parts of analysis. Bottleneck, a bottle, just a bottleneck. There's a part, there's a flow of your analysis. On bottleneck, you know that this is a pretty time, pretty a situation where the water is going to be like it's going to be the analysis is not going to be so much quick at the points of these bottleneck parts, and it could be, but it could be, for example, the let's say optimized in such a way that it will be run a bit faster. So yeah, so this is for today. Thank you for your virtual attention, and yeah, I hope we are going to meet during the next session, or ideally the beginning of the next session. Okay, so see you next time.